All right, so we're going to start 2.5 postulate paragraph proofs. You have two CLTs. I can identify and use basic postulates about points, lines, and planes, and I can write paragraph proofs. I would suggest maybe writing down these postulates because there's a lot of them. You're going to need them when you get to your homework, and sometimes it's just easier to pull them up on your paper than it is to jump to a Chromebook. All right, these notes, once again, they'll be shared with you, so if you miss something, you can always go online, look at it, and then write it down. So we have postulates. Postulates are kind of like theorems. So you can quote a postulate in order to prove something. So postulate 2.1 says through any 2 points, there is exactly one line. One line only. And a lot of this stuff you know, but you don't know that it's postulates yet. So when we're writing a paragraph proof or a 2-column proof or whatever kind of proof we're writing, if you want to say through any 2 points there's exactly one line, you just have to write postulate 2.1. That's why these are important to keep around. You don't have to write out that whole sentence, you just write out postulate 2.1. 2.2 says through any 3 points not on the same line, there is exactly one plane. So 3 non-collinear points make up a plane. That's what this is saying. Through any 3 points not on the same line, there is exactly one plane. A lot of this stuff won't make sense yet while you're getting it, but when we get to your homework, you'll see quickly. Postulate 2.3. A line contains at least 2 points. So if we look back to 2.1, through any 2 points there's a line, and now we have 2.3, which a line contains 2 points. So you're going to have it both ways in order to write your proofs. Okay, and then 2.4, once again, you have a plane contains at least 3 points not on the same line. Once again, 3 non-collinear points. Postulate 2.5. If 2 points lie in a plane, then the entire line containing those 2 points lies in that plane. So if you take, for example, the wall as a plane. If we look at one of these lines right here on the wall, you can see that it's in that plane. So that's what it means. If 2 points, so if there's 2 points on that plane, there's a line that lies on that same plane. 2.6. If 2 lines intersect, their intersection is exactly 1 point. If you think of like a Cartesian plane or just a graph where you have your x and y axis, the origin is 0.00. So where 2 lines intersect is exactly 1 point. Then you have the last one, 2.7. Says if 2 planes intersect, then their intersection is a line. Take, for example, this wall and the ceiling. Where they touch, there's exactly 1 line. Or the floor and the wall. Okay, do the ceiling and the floor have a line? Why not? What? Yeah, because they're parallel. Ceiling and the floor are parallel, they never touch, they won't have a line. All right, you're going to be determining always, sometimes, or never. So if points A, B, and C lie in plane M, then they are collinear. Points A, B, and C lie in plane M. Are they collinear? How many points do you need to form a plane? 3 points form a plane. Do those 3 points always have to be in a line? They can never be in a line, right? But on a plane, can I have 3 points that are in a line? Yeah, any line on a plane. So this is going to be sometimes. Because of the reasons I just gave. Okay? In order to have a plane, these points can either be non-collinear or they could be collinear. There is exactly one plane that contains non-collinear points P, Q, and R. Look at the postulates if you wrote them down. What does postulate 2.2 say?
Through any 3 points that are non-collinear, there is exactly one plane.
So, there is exactly one plane that contains non-collinear points P, Q, and R. Always. Because of postulate what? 2.2. There are at least 2 lines through points M and N. There are at least 2 lines through points M and N. Always, sometimes, or never. Never. Why never?
Because 2 points don't have 1 line.
What postulate says that? 2.1. Alright, they give them to us for a reason. Use them. You have 5 things, paragraph proofs, okay? This is where you have to start thinking a little bit more than usual. So, your 5 essential parts. The first part is the theorem or the conjecture to be proven. So, what are you going to prove? You're going to list the given information. Then you're going to draw it out if possible. By drawing it, it's going to let you visualize and see what you're trying to prove. It's going to make things easier on you. Number 4, you're going to state what is to be proved. Proven. And then the 5th part, develop a system of deductive reasoning. If you stick to these 5 things when you're writing your paragraphs, you won't miss anything. So let's try one. All right, we're going to write a paragraph proof. You're going to be given that M is the midpoint of line segment PQ. They want us to write a paragraph proof to show that segment PM is congruent to segment MQ. All right. What are we trying to prove?
That M is the midpoint of PQ.
That's what we're given. We're given M as the midpoint of PQ. They want us to prove that PM is congruent to MQ. How do we prove that something's congruent? What does it have to be before we know it's congruent? It has to be equal. So, does the midpoint theorem, well, you don't have it yet, but we know that midpoint divides a line into 2 equal parts, right? So the midpoint will give us PM equal to MQ. Okay, we know that by definition of midpoint, and you can write that up there. Definition of midpoint says if M is the midpoint of PQ, then PM is equal to PQ. Okay, so if those 2 are equal, then the measurement of line segment PM is equal to the measurement of line segment MQ. All right, if their segments are equal, then their measurements are equal. If their measurements are equal, then we can say that line segment PM is congruent to line segment MQ. Now, I skipped a couple of the words in there to form a paragraph, but you get how you do it. All right, by the definition of midpoint, we can say that PM is equal to MQ. If PM equals MQ, then the measurements of PM line segment equals the measurements of line segment PQ. So all those words will be included in your paragraph. I just ran through it a little quicker.
What do you mean, PQ or MQ?
PM and MQ.
You said PQ a couple times, right?
Well, the line is PQ. So the midpoint is the other one. All right, so after we do that, now we have a midpoint theorem. So now we don't have to do the paragraph proof anymore because we have the midpoint theorem. The midpoint theorem says if M is the midpoint of AB, then AM is congruent to AB. I'm sorry, MB. So if M is the midpoint of AB, then AM is congruent to MB. And if you draw it out, once again, it gets easier as you go along. All right. So I need all of you to go ahead and turn to page 91, please.